There was an alternative to using a poison, like a side, like a fungicide or insecticide, and then we knew it would work, I think that we'd all do it. There's probably a lack of solid data and research to give confidence in that. You know, I don't want to kill all my spiders and all the things that can do good things out there. We just look at alternatives to make sure the pests don't get out of control.
Insecticide resistance is a growing problem in Australia, but there's a lot of uncertainty around reducing reliance on insecticides when they've worked so well in the past. To tackle this uncertainty, Caesar Australia partnered with the Grains Research and Development Corporation and Tennyson Grower Grant to better understand how some farmers are managing to reduce their reliance on insecticides while maintaining profitability. In 2022, 2 plots were set up at the Tennyson farm. The first was sown with insecticide-treated seeds and sprayed throughout the growing season according to typical district practice. The second plot received biological additives but no insecticide treatment whatsoever, replicating the current practices employed by Grant across his farm. The plots were sown with wheat in 2022 and field peas in 2023. In both plots, red-legged earth mite numbers were assessed throughout the season, as well as other pests and beneficial insect numbers.
So we're looking at red-legged earth mite pressures. There's certain areas, particularly down south, that are running into resistance problems now, so the chemicals are no longer working anyway. You know, this is the risk that we face when you're overusing something. Nature always finds a way, and you're giving it a chance to build up resistance, and then you run out of options.
The application of insecticides at the Tennyson site reduced red-legged earth mite numbers and kept them close to zero across both growing seasons. This is the expected outcome when red-legged earth mites don't show resistance to insecticides. In the insecticide-free plot, although red-legged earth mite numbers were higher than the insecticide plot, they were kept below economic threshold levels. Beneficial abundance was also reduced by the insecticide treatment. However, in the insecticide-free plot, beneficial abundance increased in each season, helping to keep pest numbers in check.
I remember the first year we did it, when we terminated, using insecticide, we got rid of all the pests and predators, but then later in the year, all the pests were the ones that seemed to come back quicker and we still had absence of predators there. Understanding economic thresholds and things is important too, because I think too many times we see an insect and we think, oh, we got to go and kill it. If we just go and kill it every time, then what's going to feed the spider? Where we get the predators going, they can far outnumber the pests, and but it just takes that lag time for them to build. I don't think we give them credit for how much work they do in terms of cycling minerals and breaking down stubbles and eating other weed seeds or other insects. So they do a huge amount of work for us, really, if we've got them there. It's exciting to see when you start to see more life coming back into our soils.
Over 200 kilometres away at a farm in Stoneleigh, another trial was set up with growers John and Lachlan and their agronomist Craig.
John and Lachlan just didn't want to use any insecticide on the farm. They just don't like the products, so they decided not to. Just felt that it can't be good for the user and can't be good for the end product. Surely there's a way to farm without a reliance on insecticide.
The Stoneleigh site was set up in a similar way to Tennyson. The first plot was treated with insecticides and fungicides throughout the growing season according to typical district practice. The second plot was treated with fungicides but no insecticides were used. Here, the plots were sown with wheat in 2022 and canola in 2023.
The main idea of the project is that we can still grow a very highly profitable, successful crop with the use of no insecticide.
At the Stoneleigh trial, insecticide treatment kept red-legged earth mite numbers close to zero. In the insecticide-free plot, red-legged earth mite abundance was also kept low, below economically damaging levels. However, just like at the Tennyson site, insecticides reduced beneficial abundance across both years. In the insecticide-free plot, on the other hand, beneficial numbers were able to increase consistently across the seasons.
We knew there'd be low pest levels because they've used no insecticide for so long, their levels of beneficials are quite high. And that will be an issue on some people's farms, that the level of beneficials potentially won't be as high because they've got a high insecticide use. The other thing is knowing where you can and can't do it. The biggest issue we do have is coming out of a long-term pasture paddock back into a cropping phase. You will have high red-legged earth mite pressure, and so we've learnt that that first year out of pasture that canola is not the best option in terms if you don't want to use insecticide. So we've actually changed our rotation that way. So if we'd had, I don't mean to emphasise this point, but if we'd had that trial in a pasture paddock, first year in crop in canola, of course we would have had to use insecticide, the seed treatments would have helped. So it's looking at the bigger picture again, looking at your rotation, where's your risk going to be?
At the end of each season, crop yields were measured and gross profit margins calculated. Both the Tennyson and Stoneleigh sites saw only marginal differences between the two pest management strategies across both years. The results showed that, although there was a small red-legged earth mite presence in the insecticide-free plots, the healthy levels of beneficials helped to prevent crop loss. It is important to note that the trials at Tennyson and Stoneleigh don't represent all growing environments or crops in Australia. Also, the trials were only conducted over a 2-year period. However, both in the trials and in their own farms, Grant and Craig have shown that there are ways to successfully establish and manage grain systems that have a reduced reliance on broad-spectrum insecticides.
There will be scenarios, there will be blowouts where we'll say, well, if you don't do something here, you're going to have major economic loss. For what we've done here in particular, and just, dare I say, learning on the job, learning by experience, it's given us a fair bit of confidence to go forward that we can pretty much go insecticide free.
You know, at the end of the day, we're growing food, we're food producers, so if I can grow food without an insecticide or as least amount of chemicals as possible, I think it's better for us. This is where projects like this, they're really exciting to help farmers explore new ways to look at things rather than just going down the old hit it with chemical approach.